Okay, so we're going to start with example 7, and I want you to find the inverse of a domain restrictive function. Find the inverse of f of x if f of x equals x squared minus 1 if x is greater than or equal to 0. Then graph f and f inverse in the same rectangular coordinate system. So let's find the inverse of this. We're going to do this by hand. So we have f of x equals x squared minus 1 if x is greater than or equal to 0. So to find the inverse, we're going to go ahead and replace f of x with y equals x squared minus 1 if x is greater than or equal to 0. Then we interchange x and y. So wherever I see y, I'm going to put x, and wherever I see x, I'm going to put y. And this interchanges also. Now I'm going to solve for y. I'm going to add 1 to both sides. I get x plus 1 equals y squared. I'm going to go ahead and square root both sides. I get y equals, let me go ahead and before I do that, let me go ahead and just recopy this. Just reverse it, it's a little bit easier to see. And then I'm going to do the square root property. I get y equals plus or minus the square root of x plus 1. Okay, so the inverse, so I went ahead and solved for y, and now be careful here, I did the square root property here. It's a square root property. And here I get y equals plus or minus the square root of x plus 1. Y equals plus or minus. But here it's saying if y is greater than or equal to 0. So y has to be positive. So I'm going to actually disregard this. I'm going to disregard because y has to be greater than or equal to 0. So my inverse is going to be square root of x plus 1. Okay. So that's the inverse. I did it by hand. And now I want to graph both of them, both the f and the f inverse. So to graph this right here, what I'm going to do is I'm going to go ahead and look at x squared minus 1. Remember x squared is one of the common functions that we looked at earlier? So here is x squared. Okay, that's x squared. Now if I have that function, but I want it minus 1 at the end, remember that's moving that entire quadratic function down 1 unit, but now it becomes this. So now I'm going to go ahead and erase all this in red because I'm looking at x squared minus 1. And now it's saying if x is greater than or equal to 0, so I want all the x values to be greater than or equal to 0. I don't want this side of the quadratic function, so I'm going to erase this. So what I have here in blue is this function right here. So now if I want to graph f inverse, I'm going to go ahead and take all these points, 1, 2, 3, and I'm going to go ahead and switch them around or interchange them. Put that in green. So this is 0, negative 1, so I want negative 1, 0. This is 1, 0, so I want 0, 1. This is 2, 3, so I want 3, 2. And I'm going to do the inverse in a dotted line. So this is f inverse. And this is f. Notice that if I were to graph f inverse by using what I just did algebraically, this is the graph of square root of x. And in the square root of x, this graph right here, if I were to draw it with my mouse, there, there, and there. So this is the graph of f of x equals square root of x by moving it to the left 1 unit. Let's go back into our 2.5 section. So this is actually this graph right here If I move the point to the left 1 unit, there it is right there. That's pretty cool. There's about 5 different ways to get that graph on there. I can do it by hand like this way, or just interchange x and y there. Okay, so now on your own, I want you to find the inverse of f of x equals x squared plus 1 if x is greater than 0. I want you to do that by hand. I want you to graph f and the inverse, f inverse in the same rectangular coordinate system. I'm going to pause the video and have you try that on your own. Okay, so I graphed. So I went ahead and found the function, found the inverse. So the inverse is right here. So I went ahead and replaced f of x with y. Then interchange x and y, interchange to here also. Then I solved for y, used the square root property. I disregarded the negative because y had to be greater than or equal to 0. My inverse function is right here. I went ahead and graphed this. Remember, x is greater than or equal to 0, so I did not graph the other half of this. And then I interchanged x and y and got my inverse function. But again, I could have just graphed square root of x and then moved everything to the right 1 unit. And that would have been all that function there. Okay. So that last example I did, and on your own, pretty difficult for a lot of students. That problem will be on your exam, so just make sure you understand how to do it. And if you have any questions, just let me know. But at the end of section 2.7, and we're at the end of chapter 2.